Good day everyone, welcome to Bright Engineering. Today we are going to look at induction in terms of multiplicity and then divisibility. So we have a question that we are to use induction to prove that indeed that particular question is a multiple of 8 and 1 which is divisible by 3. So in this case, like I said, no matter what the question is, induction takes 3 forms or 3 stages. We have the testing, the assumption, and now the proving. Right, so for the first question, 3 raised to the power 2n all minus 1 being a multiple of 8. Now, first of all, we are going to test it to see if indeed this question is a multiple of 8. So now, we are going to test it with 1. So when n is equal to 1, we are going to get 3 raised to the power 2 times 1 minus 1, right? And we know that this is going to give us 2, so 3 raised to the power 2 is going to give us 9 minus 1, and then the answer is 8, right? So ideally 8 is a multiple of 8, right? Because this is the same as 8 multiplying something which is 1. So this is a multiple of 8. So if this is true for the testing stage, now let's go to step 2 and then assume. The assumption stage, right? So when we assume, that means that wherever we see n, we will let n be equal to k. So when n is equal to k, we are getting 3 raised to the power 2k minus 1 is equal to 8d. So the question is, where from this 8d? Mind you, I said that for the stage 2 or the step 2, we are just assuming that because that we were able to prove for this testing stage, it means that for the assumption stage 2, it is also true. So it means whatever we solve, we should get 8 multiplying something. Just like here, we had 8 multiplying 1 to give us 8. So whatever our answer is going to be 8 multiplying something, right? So now, here we can just leave it like that. But in this time round, we can just express this as 3. This is 3 2k, right? So it's the same as 3 raised to the power 2 times k, right? Sorry, times k here. Minus 1 is equal to 8d, right? So we can just say this is 9k. So we get 9 raised to the power k. And then we can send this one here to get 8d minus 1, right? So now we've made the expression with the k stand alone. Now the step 3, which is the proving stage. Now we are going to prove that indeed when n is equal to k plus 1, we are also going to get an expression like this. So now when n is equal to k plus 1, we are going to get 3 raised to the power 2 into brackets n is k plus 1, so k plus 1 minus 1. But this time around, we are not going to equate it to 8 something, right? Because we are going to prove with this that truly is equal to what we've been saying or what we've been talking about. So here we can just write 3 raised to the power 2k multiplied by 3 raised to the power 2, right? Because when the powers are added, it's just like when the bases are the same, you can add the powers. So 2k and then 2 is like this. So we can just omit this base and write 2k plus 2, right? Minus 1. So this time around, we are getting this to be 9 raised to the power k times 9 minus 1, right? And from here, we know that 9k is the same as 8d minus 1. So we can just substitute that in here. So we are getting 8d minus 1 multiplying 9, and then we have our minus 1 here already, right? So here we are getting 9 times 8d, right? You can just use this dot to represent multiplication, or you can ideally multiply it to get your answer, right, which is 72. But then I will choose to write it this way. And 9 times this is going to give us, sorry, this should be plus 1. You have minus 1 here, so when it crosses to this side, it has to be plus, right? It has to be plus 1. So this is supposed to be plus 1, yes. So 9 times 1 is going to give us 9, so plus 9. And now we have our 1 here. So 9 minus 1 is going to give us 8. So we have 9.8d plus 8. So here 8 is common to both sides. So we can just bring 8 out and get 8 into bracket 9d plus 1. So now our expression is 8 multiplying something, which is 9d plus 1. So it means that this whole expression is a multiple of 8 because it has 8 multiplying something. Please, I hope you understand that. Now let's look at the second example, which is the divisibility, right? Now 2 n cubed plus 2n is divisible by 3, right? So just like we did, we are going to start with the testing stage. So step 1, testing stage. We are going to test it with 1 as usual. So when n is equal to 1, we are going to get 1 cubed plus 2 times 1, right? And this is going to give us 1 plus 2, which is equal to 3. And like we said, when you have 3, it's the same as 3 times 1, right? So it means that yes, this is divisible by 3 because 3 goes into 3, 1, right? So this is also true. Now, like I said, it's not always that you are going to test it with 1, but in instances where you are not supposed to test with 1, the question will be specific and may probably give you something like when n is greater than or equal to 2, then you know that you can start from 2 or any other number that it gives you, right? So step 2, which is the assumption stage, we are now going to assume. So when n is equal to k, wherever we see n, we put k there. So we are getting k raised to the power 3 plus 2k. And now it's going to be equal to 3 multiplying something, right? Say 3m. Please, I hope we get this one, right? So now this time round, we can just choose to represent this whole thing, make this stand alone, and get something like k cubed is equal to 3m minus 2k, right? So when we get something like this, then we know that we are good to go. Now, step 3, which is the proving stage. And when n is equal to k plus 1, wherever we see n, we put k plus 1. Right, so we are going to get k plus 1 all cube plus 2 to bracket k plus 1. As usual, we are not going to equate this one to anything that has 3 in it because we are going to use this one to prove it, right? So if you expand this, if you have to expand this, we are going to get k cubed plus 3k squared plus 3k plus 1, right? Plus 2k here and then plus 2 here too. Please, I hope you understand it, because if you are expanding this, it's supposed to have 1 3 3 1, like we already know, right? So as it's going here, the k will be decreasing and then the 1 will be increasing, right? So here it will take all the k to cube no 1. Here the k will come to squared with just a 1. Here the k will come to just k with 1 squared, and here it will take all the 1 to be 1 cube, which is going to give us 1, right? So take notice of that. So here we have only one expression for k3, or k raised to the power 3, and then for the k squared, one expression which is plus 3k squared. And now we can add the k's, which is 3k plus 2k. We're going to get 5k, right? And we can add this and this to give us 3. But then we know that k raised to the power 3 is the same as 3m minus 2k, right? So we can just represent this by this expression, and we are getting 3m minus 2k plus 3k squared plus 5k plus 3. So the only expression with a squared is this one. So we can write 3k squared here, and we have 5k minus 2k, which is going to give us plus 3k. And we have 3m here plus 3m and then a 3, right? So we can, looking at it, it all has 3 in it, so we can just bring 3 outside to get 3, and now into bracket we are getting k squared plus k plus m plus 1, right? Which is the same as 3 multiplying something. And ideally, if we are to divide this expression by 3, we are going to get this expression. So it means that our proving stage is right. This is divisible by 3. If this video has been helpful, please don't forget to subscribe to the page, like, comment, and then share. Thank you very much.